Show that convolution of two rectangular signals produces a triangular signal. So for a rectangular signal, unit rectangular signal, the plot is as shown in this figure. So it is defined from minus half to half and its amplitude is 1. So unit rectangular signal over area will be A is equal to so length into height. So its width is equal to 1 and its height is equal to 1, so it is 1. So unit area means unit rectangular signal. So now you see that this signal, rectangular T signal, this signal can be written as a sum of these two signals, ut plus half and ut minus half. So ut plus half is defined from t is equal to minus half. If you put t plus half equal to 0, then t is equal to minus half. So it originates from t is equal to minus half, and this signal t minus half originates from t is equal to half. So if you subtract these two signal, if you subtract these two signal, then you will get from minus half to plus half. Minus half to plus half, its amplitude is 1. Then after that 1 minus 1 becomes 0. So it is defined from minus half to half with magnitude 1. So this rectangular signal is written as by this equation ut plus half minus of ut minus half. Okay, so we have to find the convolution of these two signal, rectangular signal, and show that the output becomes a triangle. Okay, now if we start from this point, that say yt is equal to rectangular t convolution with rectangular signal t. So now we replace this rect t using this step signal relation. So ut plus half minus u minus of ut minus half. So if we convolute this to signal, so using distributive property we can write like this: ut we can convolute with this signal, and next convolution of the signal with this signal. So we can write here ut plus half in convolution with ut plus half for the first convolution. Then negative symbol is there, so minus comes here, and ut plus half into u of t minus half. Similarly, in multiply these two, convolution of these two, you can write here ut minus half, the third term, ut minus half convolution with ut plus half, and last term ut minus half into ut minus half. So there is a negative symbol between these both component, so that is why this signal is becoming plus half. Okay, now you see that we know that the convolution of two unit step signal is a ramp signal. So ramp signal is nothing but this convolution of two unit step signal, okay, produces a ramp signal. So ramp signal is like this. Okay, so it is given as tut. So these are ut unit step signals. So we know that this, so since these are two unit step signals, so you can write here rt, but there are shifted signal t plus half and t plus half. So overall shift in the output will be t plus half, and plus half means becomes 1. Okay, so overall shift is t plus 1. So rt plus 1 is the output of this convolution, and this signal and this signal, these are same signal, only t plus half convolution with t minus half. So we can write this 2 as minus of 2 of this. Okay, and last plus this means this is same signal, so you can write rt. So shift is minus of becomes minus 1. Okay, so now these two convolution you can write here 2 into rt for this, and this shift plus half and minus half becomes 0. So that is why you can just write t here, no shift, additional shift is 0, so you can write minus 2 rt. So this is first component, this is this component, and this component here. So this is the overall signal yt, output of this two rectangular signal. Now we can show that this equation yt represents a triangular signal. Okay, so for showing that we can plot the signal like this. We know that. Okay, We know that for RT it is TUT. For RT it is TUT. Okay. For RT plus 1 it is a shifted version. Okay, so this line becomes T plus 1, or for T minus 1 it becomes T minus 1, so like that. So now you see the earlier signals, rectangular signals. So now if you plot this signal, okay, so from -1 to 0, the equation of this line, you can see this RT plus 1 is defined for t is equal to -1 to infinity. RT is defined for t is equal to 0 to infinity. RT minus 1 is defined from 1 to infinity. So it starts from 1, it starts from 0, and this starts from -1. So for this limit -1 to 0, you will get only this first component RT plus 1. This is nothing but t plus 1. For the second component 0 to 1, so this signal will be there already. So and from 0 to 1 you will get this part also. So you can write RT plus 1 minus 2 RT. So t plus 1 minus 2t. So you get this expression for yt. For t greater than 1, you will get all this component of the signal RT plus 1 minus 2 RT plus RT minus 1. So these are RT plus 1 is represented by this line equation t plus 1. This is for this and this is for this. So if you add these two components, then you will get 0 for t greater than 1. For t greater than 1 you will get 0. Okay, so if you now plot these three parts, for -1 to 0 the equation is, line equation is t plus 1. Okay, this is the equation for t plus 1, and from 0 to 1 the equation is 1 minus t. So this is the equation for 1 minus t. Okay, this is the equation for t plus 1, and for t greater than 1 it is 0, so we are not getting any single component here. So the plot becomes like this. Okay, so if you plot t plus 1 and 1 minus t, you will get this type of line. So this already you know. So this ultimately this yt signal looks like this. It is a triangular signal and unit triangular signal. So that is why you can say that the convolutional output of the rectangular signal produces a triangular signal.